Hello, and welcome back to our latest event here at CloudAppDevs. It's been a while since we last hosted one, so I believe it was summer. Apologies, I had some echo for apologies for that. But as I was saying, it's been a while since we last hosted one. I believe it was just before summer. But we're very excited to be here back again, sharing two great talks with you today, which are going to be around the topic of security in Kubernetes. So without further ado, let me introduce our first speaker. His name is Ole Lensmar. Hi, Ole.
Hey, Steve. Nice to be here. How are you?
Nice to have you here. So Ole is the CTO and founder at KubeShop. It's a company that many of you already probably know. They specialize in many different open source projects within the cloud native ecosystem. And today, Ole will be talking about Kubernetes policy enforcement, as he calls it, the good, the bad, and the ugly. So Ole, I don't want to take any more of your time. We don't want to start running in late. So I will leave you to it, and you can take the stage.
Awesome. Thank you so much, Steve. Well, I'm going to start by sharing. Let me see here. There you go. I hope, can you see my screen now? There you go. Thank you so much. Awesome. So thanks for the intro, Steve. Great to be here talking to you about the good, the bad, the ugly of Kubernetes policy enforcement. Let's just jump straight in. I'm at KubeShop, CTO there. As Steve already mentioned, KubeShop is an accelerator for open source startups that target cloud native and Kubernetes. Monocle is one of our projects that I'm going to be talking about, which is all about policies. We also have TestCube, which is a testing framework for Kubernetes, TraceTest, which is end-to-end testing based on OpenTelemetry, KubeFirst, which is everything you need to get started with GitOps, and BotCube, which is for monitoring and debugging Kubernetes clusters. All open source. You can check them all, find them all out on GitHub and on our website. But today I am going to be talking about policy specifically. So let's just first of all get this straight. What do we mean by policy enforcement? And before this talk, I actually had to ask, our source of truth, ChatGPT, and ChatGPT came up with a pretty good definition: the process of ensuring that established policies, rules, regulations, or guidelines are followed and enforced within an organization, system, or community. And maybe dialing that down a bit and looking at Kubernetes specifically. There's really two types of policies that can be enforced. There's configuration policies, which are rules that apply to your YAML configurations. As you probably know, Kubernetes is pretty, close a lot about YAML. And those rules can be, of course, about security, which is maybe what most people think of when they get started with policies, but it can also be around resource usage, resource allocation, how much memory you're allowed to use, how much CPUs, whatever other kind of resource allocations that might be applicable, best practices, and how you kind of connect different resources to each other, how you configure them, how you use config maps, how you use secrets, things like that, and then just conventions, right? These could be specific to your own project or to your own organization. This could be naming conventions, it could be labeling conventions, annotation conventions. It could really be anything, really, from very, very high level or very to very tactical when it comes to your specific applications. Then there's also runtime policies, which are policies that aren't really applied to the YAML, but they're actually applied to the runtime. So I think network policies is the most obvious one that you might be aware of. So network policy is something that you define in YAML, but then is that enforced at runtime to make sure that your pods or whatever are constrained to the network policies that you've configured. So it's kind of the high level what policy enforcement is. It sounds maybe a bit enterprisey or hard, but it's not really. It's about getting your YAML right. And if you've used any IDE that you're doing linting on your code and with any language, that's also kind of policy enforcement, right? You want to make sure that you have the right indentation or whatever else. So it's really that same thing, but for your YAML configurations in Kubernetes. You might ask, why do we need policies at all? If you've been using Kubernetes for a while, you know that Kubernetes configurations are really, really complex, right? You can have hundreds, thousands of YAMLs, and it's really easy to get something wrong. These versioning of how these YAMLs have evolved over time, or how the schemas for these configurations have evolved over time. It can be easy to get something wrong, to not maybe always comply with how things should be. You can use policies as a contract between different roles in your team. So your developers, your security engineers, your ops, SREs can kind of align on a set of rules. And that's a great way to kind of get collaboration and communication in your team going, trying to get together. Okay, how are we going to, what can we agree on, how we're going to work with our YAMLs, what needs to be in there? And which, it's always good to talk to each other anyway, but doing it in a way that also helps you, create safer deployments or have a better deployment success ratio is, of course, a good thing. And as I'm sure you're aware, that if you get these configurations wrong, that can have severe consequences. If you, by mistake, or don't give maybe your pods too much privileges, and then that pod might contain a security exploit which makes use of that privilege. It could reap havoc in your system. I'm sure I'm not going to give any examples here, but I'm sure you can find online. So I think it's easy to see that not maybe following some basic rules in your YAML configurations could put you at risk, but it's also easy to see that for someone that's not security minded, that's just focusing on getting their application working, it might be hard just to know about all these things. So once again, having policies in place to help you get all those things right can be really, really important. Really, really high level on how are policies actually defined. And it depends. There's a bunch of policy frameworks out there. I'm just going to mention a couple. Kyverno is a CNCF project, uses a declarative approach with YAML. So basically you use YAML syntax to define your policies and how they're applied. A more imperative approach is maybe more common. Kubernetes 128 introduced validating admission policy resources, which is a combination of YAML and CL, which is a common expression language. Rego, which is used by OPA, which is a complete language for writing policies, not specific to Kubernetes. You can use OPA and Rego in a variety of scenarios, but it also works really nicely in Kubernetes, as many of you are probably aware. Also other tools like KubeWarden support OPA. TypeScript is another common language that I think a lot of people know and love or hate. Monocle, which is the tool I'm going to show you, uses TypeScript to create custom policies. KubeWarden, once again. And then there's a bunch of other tools. Mentioned KubeWarden again, which also supports Go, but if you Google, you can find a variety. I think what we are seeing is that now that Kubernetes is embracing policies through the validating admission policy introduced in 128, that's likely way to go. That's probably a good place to start if you're new to creating your own policies. Lastly, I'll mention by specification. And what I mean by that is that Kubernetes introduced what's called the pod security standards not long ago, which define a complete set of rules that can be applied to namespaces in your cluster. So it's a very coarse-grained way of applying a policy, but a good way to get started. Here to the right, you see a simple example of a validating admission policy. Here at the bottom, you can see a very simple CEL expression, which and then to which resources that expression is applied. So pretty straightforward if you're reasonably familiar with any kind of program. Maybe a big question then is, when could policies be applied? And I think I'll take this backwards from what you might be used to. So you could apply them before you commit your code, right? So in your CLI, with using CLI tools or an IDE extension or a plugin, you could apply them before you merge, all right? You could have a CI bot validating your pull requests, or you could use some CLI tools that you automate as part of your pipeline. You could apply them when you deploy, which is maybe the most common place to start today. You have an admission controller like Kyverno, OPA Gatekeeper, others that just check every resource YAML coming in to make sure it complies by the policies before it actually gets admitted to Kubernetes. Or you can apply policies at runtime, as we already mentioned initially, either using API objects available in Kubernetes or using a tool that allows you to connect to your cluster and validate, inspect what's in there and making sure that everything is compliant. Bigger question then is maybe, when should you be applying policies? And we've heard a lot about shift left, I'm sure, and discovering and applying policies early in the life cycle, so pre-commit, as I was showing in the previous slide, is a great place to start, right? It saves loads of time when it comes to troubleshooting, and it's great to get, the more you get right from the beginning, the more time you save later on in the life cycle. But there are a bunch of caveats with that. And I'll just list a couple here. One is that applying a policy early on is not always possible. You might need access to the cluster itself to know, to be able to evaluate the rules, right? Maybe you're referring to a config map in your objects that isn't available in your local files, but it's available in your cluster, right? So a policy that would validate the availability of that config map would fail locally, but it would actually work, although it's actually totally fine because that's running in your cluster. Another problem is that your policies will probably vary across target environments, right? So for your production environment, you have very rigorous policies around security, but for your staging or testing or dev environment, you won't. So how do you apply that locally, and what kind of level do you apply locally, and what do you apply in various stages of the pipeline? And another one, which is important, is that locally enforced policies can be bypassed, right? I can always kind of just turn off that validation in my IDE and just commit my stuff anyway, or I can do, commit directly, merge or make a change directly to main in GitHub, although you're not supposed to. So having that safety net for in-cluster enforcement is always a good idea, right? So I'm definitely saying that, not saying that you should only do shift left early on. You should definitely have those security controls in place later on in the life cycle as well. And speaking of shift left, it puts a lot of burden on, just shifting everything left and hoping that people upstream are going to fix the problems. That does put a lot of burden on those people because they're usually not allocated more time to do so. So you really need the communication, and we talked about that earlier, but also the culture regarding in relationship to the way of this kind of way of working with policies. Okay, that was a really, really quick rundown of policies at a very high level. I'm going to talk a little bit about Monocle now. Monocle, which is a complete tool chain for Kubernetes policy enforcement, right? So all the way from the left in that pipeline to the right. So there's a Monocle Cloud tool, which is a centralized policy management platform. And then there's a bunch of open source tools, Monocle Desktop, Monocle CLI, there's a VS Code extension, there's a GitHub app, there's a Chrome extension, and there's an admission controller. So really kind of helping you enforce your policies, manage them centrally in cloud, but then enforcing them in all those points that I mentioned in the pipeline. And just to color it up a little bit, just to show you, so at the bottom here, you have what we like to call a policy enforcement pipeline. So to the left, you have your local tooling where you do pre-commit validation, and that's where you would use Monocle VS Code or Desktop or CLI. Then you have your SCM or your Git provider. That's where you would do pre-deployment validation using a GitHub bot or a CLI once again. And then when you have things in your cluster, there's a Monocle admission controller. And then when things are running in your cluster, you can also use Monocle Desktop to actually connect to your cluster at runtime and validate policies. So this is actually, you might think of it, it's like a last resort, but it's actually where most people start from our experience, is that they say, oh, they realize we need policies, we need to start checking what's running in our clusters. So they use Monocle Desktop to just connect to the cluster and start validating some rules against the resources in their cluster, just to see, okay, what problems do we have, and maybe even applying some immediate hot fixes. So it's all in there, and then Monocle Cloud as kind of the tool to tie these all together with centralized policy management. So why would you use Monocle? I hope I've been clear on that. Centralized policy management across the entire lifecycle. We have a powerful validation, an auto-fixing and suppression engine. I'm going to show that in a little bit. And it integrates into your existing workflows, hopefully, right? So once again, thanks to all the different tools that we have, we try not to say you have to start using a very different tool. You can continue using VS Code or GitHub or whatever else. And hopefully we kind of fit nicely into that. And if we don't, you should let us know so we can improve our ecosystem and open source tool. What about other tools? Some of you are probably already doing policy enforcement, which is great. So if you're already using something in your cluster like Kyverno or OPA Gatekeeper, You could use Monocle for pre-commit or pre-deployment validation as a complement. There's a bunch of features in Monocle to validate your dry runs of Helm and Customize, and using all the policy management and governance. So it's not one or the other. These work nicely alongside each other. Or if you're already using a pre-commit tool like kubelinter, and there's a bunch out there to kind of just make sure your configurations are valid locally, you can use Monocle once again to complement with more advanced policies, with custom policies, which is very easy to create in Monocle, or then with the pre-deployment or in-cluster validation. So it really depends on where you are. We like to think that we can play nicely with everyone. I'm sure it's a bit of wishful thinking, but there we are. And if you're the kind of person that has it all figured out and it's all working, congrats to you. Please get in touch. We want to learn from you and what challenges you have and how we can make sure that a tool like ours could have solved your problems before you solved them yourself. How would you get started with Monocle? You could go to Monocle Cloud to look at your existing repos. You can try Monocle Desktop to work with your existing configurations locally, or you can use the VS Code extension or the CLI just to validate YAMLs that you already have without kind of diving into one of the other tools. And as I said, the desktop VS Code CLI are all open source tools, so there's no, I'm not going to ask you to sign up for anything or anything like that. You can just download them or install them with Brew, and VS Code, you get it from the VS Code marketplace. So all good with that. Okay, and I have, well, it's a little bit 8-9 minutes, so I'm going to try to do a little bit of a demo. So I am going to start with Monocle Cloud. So when you sign into Monocle Cloud, you're initially just going to be asked to, how you want to start. And there's either you can start by just looking at one of your existing repositories on GitHub that contains your YAML configurations, or if you're, if you know what you want and you've kind of get the whole thing, you can start by setting up guardrails for your teams. I'm going to start with the first one here because I think that's the more obvious one. Once again, if you're not using GitHub, you can use Monocle Desktop to do much of these things instead, which works with any Git provider or any local file. So those, those configurations could come from Azure DevOps or GitLab or, you name it. So I'm just going to do that, and I'm just going to select a repository of mine, and it's a really, really simple repository. Monocle is going to ask me for a initial policy, so the rules I want to validate. I'm going to select the Kubernetes version, which Monocle wants to know kind of to enforce the right schemas and versions of my objects. And then I'm going to select two security frameworks out of the box. This might be hard for you to know where to start, so this using the restricted pod securities and Kubernetes hardening guide by NSA CISA is a good starting point. And you can toggle and fine tune these policies, at length once you're in the tool. I'm not going to enable pull request validation because I don't need that for the demo. And then I'm just going to go straight into the IDE. And I'm not going to walk through the guide, but what we need to immediately see here, I'm just going to jump a little bit back and forth. The project here I have is just two YAML files, one containing a deployment and one containing a service. These two are, referencing each other. And when I went into the IDE, Monocle's automatically put me into what we call the View Fix Mixed Configurations panel. So here I can see the different problems that were found, and you can also, hover over the different errors in the YAML files itself. These are the different, some of them were errors, some of them were warnings. And the nice thing here is now there's a small autofix wand here, I guess. So I can actually just start clicking here. And as you can see to the right, Monocle is going to apply autofixes to the YAML and fix those violations or errors that it found. And some of you might be thinking, that's not always a good idea, right? You don't always want people just to lazily click autofix and not learn because, the next time they might not have such a fantastic tool at hand and they're just sitting with the YAML ID and they won't have learned and they won't know how to fix these problems manually. So definitely a two-edged sword when it comes to autofixing. But on the other hand, if you are a person who does know what you're doing, this is saves you a lot of time, right? You can just basically click through many of these or warnings and then look at the YAML that was created and make sure that it's all good. And then I can up here just directly commit this to GitHub from here. I can even create a new branch and kick off the whole pull request process. I can also suppress errors here. So what I'm going to do here instead is I'm going to do some suppressions. And what this has done now is instead of fixing the errors, I'm suppressing them. I'm saying ignore them. And why would you do that? Well, not always. It's not always that you actually want to enforce a rule. Maybe it's totally okay for this specific deployment to not enforce a valid seccomp profile. So there's that functionality to allow you to suppress them. And an extension of that function I'm not going to show you here because it takes time is that there's a workflow in Monocle where if you are a developer, you can request a suppression, which would then have to be approved by an admin. So it's not that I can also then once again lazily just suppress everything and I'm good to go. In that case, someone else would have to actually approve the suppressions, or they could even be removed. So we can actually look at what that looks like. I'm going to go back into the project view. There's a suppressions tab. And here you can see that these were the 3 suppressions that I had requested. Let's just remove them and go back to the repo. And then now you can see that these are not suppressed anymore, right? So then I'll just use the autofix instead. And now everything's fixed, and I could actually now commit this, and hopefully, you know, I have a much secure deployment that I could push into my cluster, and everything is good to go. Okay, that's the one thing I wanted to show. The other thing I wanted to show is the VS Code integration. So I'm going to switch to VS Code. So here I have another repo with a similar, actually almost the same kind of sample project. For now, this project is not, this repo is not connected to a Monocle Cloud project. So we're just not seeing any validation errors or anything like that from Monocle. So let's just jump back here and go into our project here and add this repository, which is GRDMO4. Who would have guessed? So now this repository that I have locally in VS Code is now also being governed here. I can see in the policy tab the actual rules. Sorry, I forgot to show this. These are the actual rules that are being enforced. And you can see here I can toggle them on and off. I can assign warning and error levels. And there's a lot I can do here. But since I'm almost out of time, I'm not going to do that. Let's just go back here. And now you can see while we were looking at that, Monocle, the VS Code extension has now discovered that my repository is now actually connected and being enforced. And now I can see that the same errors that I saw for the other repo, this is basically the same content, are now actually being shown here locally. So what the nice thing is here is that I can centrally define my policies, and then anyone who's using VS Code with or any of the other tools can then enforce those policies and make sure they're complying by the same rules. So I'm just gonna, I don't know, there's a seccomp profile here rule just to kind of once again show you how this works. Let's find that rule, enforce. Let's just turn it off. I'm going to save that, and let's just jump back to VS Code, and I'm going to do synchronize. Now you can see that that rule is no longer being enforced since I've disabled it in Monocle Cloud Policy Manager. So that's all I was going to show. So the VS Code integration and using Monocle Cloud as that centralized policy management tool. And that's it. I think I have 30 seconds to go. So thank you so much for listening. Please get in touch if you want to learn or see more about Monocle or any of our projects. You can email me, ole@kubeshop.io. You could go to monocle.io. There's a Discord server where you can complain or praise or ask questions. Obviously, you can find me on LinkedIn and anything else. We'd love to hear from you. Any challenge that you have with policies and anything of the like, we love to learn. Thank you so much.
Thank you, Ole. Yes, I would just like to share, we have a few minutes, so before we give way to the next speaker, if you could just answer one of these questions. Let me see if you can, I believe you should have it on the screen now.
Sure. So as I mentioned on the call, so we definitely see users using Kubernetes, but wanting to do a more kind of pre-commit early validation. So as I mentioned, you can complement, right? So you can have Kubernetes doing the in-cluster validation, which is great. And then you could use Monocle, just as I showed you here, basically. You could set up corresponding policies to the rules that you have in Kubernetes and then enforce them in VS Code, etc. So they work very nicely together. I mean, even nicer if Monocle would actually understand Kubernetes policies. We're not there quite yet, but it's definitely something we're looking into.
Excellent. Well, Ole, thank you so much for sharing your time with us. It's been a very good talk for us, and we look forward to seeing you in future.
Thank you
And
so much, Steve.
we'll let everybody know in the follow-up to the event how to look at the projects from KubeShop and see if they would like to contribute to any of these great open source projects you guys have going on. Okay.
Thank you so much.
Bye-bye. Bye-bye. Okay, so now with that, I don't want to delay this. We're going to introduce Alba Ferri. She's a senior product marketing manager at Sysdig. Alba is a seasoned engineer. She's got many years of experience as a product manager. Hi, Alba.
Hello, how are you? Good afternoon.
Excellent. So as I was saying, you're going to be presenting a talk on best practices for securing cloud and containers, which I believe is also going to include a short demo as well.
That's right. Yep.
Excellent. So Alba, I'll leave the stage to you.
Okay, thank you. So hello, everyone. Welcome to this second session of the Meetup. I'm going to start by saying good morning, good afternoon, or good night, depending on when you will watch the talk. For us, attending the meeting live is good afternoon. So as Steve said, my name is Alba Ferri. I am based in Madrid, Spain, and I'm the Senior Product Marketing Manager for the CSPM domain at Sysdig. So today's session is 5 best practices for securing cloud and containers. And as many of you may know, Sysdig is a cloud security platform focused on containers and cloud. So we have a broad range of customers from all sizes and industries. And over the year, that has provided us very interesting insights about what are the best practices that organizations can apply in order to keep track with cloud and containers. So in this session, I'm going to share them with you. We know that cloud and container security are a constant concern for organizations. Not only security and DevOps teams need to continuously evolve and fine-tune their knowledge and skills, but actors are also doing the same thing. So I hope this talk serves as a valuable guide to formulate the security strategy of every organization that is about to transition or taking their first steps towards moving to the cloud. And I am going to share my screen. Let's see, because I was talking and I wasn't sharing this one. Okay. So I guess you're seeing my screen, right? The slides. Okay, so I'm going to keep up. Okay, so let's set up some industry context first. If we think about how was IT security 20 years ago, we would see that services were deployed in data centers, on servers that were close to each other, sometimes interconnected physically, and data had only one way in or out of that data center, right? Security was based around a perimeter. Our realm was easily protected through firewalls, like a medieval town surrounded by high, thick walls, limiting traffic and attacks through solid doors and defended through thin arrow slits. Nevertheless, today it feels that everything is happening everywhere all the time, right? There are problems that security teams didn't have to deal with back on the data center days because the contracts were just not the same that they are in the cloud. Nowadays, services are distributed and operate in environments with not so clear limited perimeters. Developers, operators, and users are located around the globe. Services are no longer confined to a single place where there's only one way in or out. If before we compare our infrastructure to a medieval town, now it is more like an amusement park. an amusement park full of attractions, multiple entrances and exits, and many more chances for actors to behave unexpectedly. A distributed infrastructure based on cloud technologies that require detecting threats from myriad of sources. And here there are many actors interacting in many different ways, that the number of the potential events and the amount of information that needs to be monitored has increased exponentially. So in the cloud, there are more opportunities for things to go wrong, and we need to be ahead of that because the impact of things going wrong is much worse here. Verizon 2021, the BIR report said that external cloud assets were more common than on-premises assets in both incidents and breaches. And let me expand a little bit what this sentence means. When it comes to security incidents and data breaches, external cloud assets, so those hosted in external cloud environment, cloud service providers, were more commonly involved or affected than on-premises assets, those hosted on an organization-owned infrastructure or managed data center. I'm sure we all understand what this is suggesting, right? Organizations face a higher risk of security incidents and breaches related to their cloud resources compared to their on-premises infrastructure. We have reached the point where incidents and breaches are occurring more frequently in cloud environments. And let me do a recap on what I've just been talking about. So how security has changed in these 20 years. How has the landscape evolved since the area of perimeter-based security within on-premises data center and the birth and steady adoption of the cloud? One of the most notable changes is this shift that I was mentioning from a perimeter-based security model to an identity-centric approach. So in the past, security teams largely relied on fortifying the network perimeter. So only IT for provisioning and security teams were involved in the task of creating and managing infrastructure. Today, with cloud adoption and remote work, many other teams are involved in the process. So DevOps create their own resources, developers code into serverless functions. So not only IT or security anymore, right? In the early 2000s, most IT infrastructure was hosted on premises within an organization data center, right? This meant that IT changes primarily revolve around managing physical servers, networking equipment, and storage devices. Organizations needed to predict future infrastructure needs and procure hardware accordingly. Software deployments and config management processes were typically rigid and time-consuming, with a focus on minimizing disruption to on-premises operations. So to sum up, IT changes were typically manual and slow. In the cloud, resources can be provisioned and deprovisioned dynamically. IT changes are automated, allowing for rapid and consistent deployments. Development teams can iterate quickly, releasing updates and features faster. And cloud adoption in general has introduced flexibility, scalability, automation, right? Let's talk now about the technology stack. During the 2000s, IT departments often operate in silos with separate teams responsible for servers, networking, storage, and applications. Each layer of the technology stack had its management process, so the stack evolved slowly. The cloud era has introduced greater agility, scalability, flexibility, allowing organizations to focus on delivering value through software and services rather than managing physical infrastructure. And the last thing that has experienced a dramatic change is the scope. The scope of security has expanded from being primarily production-centric to encompassing the entire source to production lifecycle. Security is now integrated into the development processes and practices like DevSecOps, postcode, shift left have become essential for ensuring security at every stage. This shift reflects a proactive approach to security with a focus on prevention and early detection of vulnerabilities and threats throughout the software development and deployment process. So the move from perimeter-based security to identity-centric and zero-trust models, coupled with cloud adoption, new threat vectors, and advanced technologies, has heavily reshaped the way organizations approach to security. And talking about those new threat vectors and advanced technologies, I'd like to draw attention specifically into supply chain attacks. Software supply chain is rising as a top concern across the board, from C-level executives to security practitioners. Malicious software supply chain attacks are increasing in an alarming rate. 2022 saw another more than 600% of year-over-year increase, to the point that the governments are already taking actions. The US issued an executive order to improve cybersecurity. The European Union, Japan, and others are also following similar path. And the reason is simple. Software supply chain provides the modern digital foundation, and we are increasingly dependent on it. This timeline here shows a sample of what organizations of any size in any geographic region, sector, or industry are facing. From the shockwaves sent by the SolarWinds attack, with silently deliver the sandbars backdoor inside 18,000 customer organizations, to Log4j vulnerability, which this time exposed the world due to this library popularity, right? To the more recent attacks to development platforms like CircleCI. So it's clear that the software supply chain is an strategic entry point for cyber criminals. So what we can learn from this timeline is that data breaches and threat attacks are continuing to happen, and there are no real signs of an end anytime soon. So this leads us to the challenges facing cloud security today. As more companies move to the cloud, they are facing similar security challenges as before, but on a larger and more complex scale. There are so many different areas of security that you need visibility into if you want to stop malicious actors from entering your environment. For example, continuous releases through CI/CD often result in a massive vulnerability backlog, making it hard to manage risk without overwhelming developers. But devs, they are under pressure and to ship apps, and vulnerabilities sometimes make it through. In fact, our latest cloud native security reports show that 87% of container images running in production have a critical or high vulnerability. Managing configurations is also daunting at cloud scale. With thousands of resources deployed across multiple cloud accounts, how do you make sure that every resource is configured correctly? Cloud misconfigurations are still a significant source of breaches today. We often hear about the challenge of extending access management policies to cloud accounts across human and machine identities, and our data shows that 90% of cloud permissions are not even used. Containers are also short-lived. In fact, our report shows that 72% live fewer than 5 minutes. So how do SOC teams, for example, go about doing any kind of threat or breach investigation without data or context? So we're living in this cloud-native world with thousands of containers, cloud services, identities, permissions, third-party apps to protect. But the problem is that these are all addressed with different tools, like we were doing before, working in silos, right? And workflows making cloud security challenging at scale. But there are always best practices that we can follow to reduce the blast radius, right? So let's get into these 5 security best practices that we recommend in order to secure cloud and containers appropriately. And please note that these are just guidelines designed to cover like a general majority of cases. However, they may vary depending on the unique requirements that each of your organization may have. Okay, so the first one would be shift your security left. Big buzzwords, right? Shift left. A lot has been already commented about shift left, but let's refresh our minds on what it means. So shift security left revolves around thinking about security earlier in the process of shipping your cloud apps to production. Means that you need to include security while in the process of building the infrastructure that is going to run your applications. So if we picture that process for a moment, we normally have different phases, right? Like code, build, production. So code would be the farthest left. Then we have build, and finally our apps or services go to productive environment. So left to production, the actions that you take before a workload or a cloud service becomes productive is where we now should be including security controls. And let's make sure that we are checking things, that we are locking things down, we're configuring things correctly, because that is going to help us avoid getting stopped by security issues. That early we will have us reconfiguring our app or our cloud service and fixing things later on in an emergency pace that we don't want, right? So shift security left means that we want to be able to scan our infrastructure as code artifacts properly, hopefully earlier in the process, in the CI/CD pipeline, if you're able to do that. So let's scan while the IAC resources are still on dev phase before they go into Jenkins or Argo CD, the build pipeline, giving teams visibility into misconfigurations immediately there, as opposed to waiting until it finishes all the provisioning, right? Or potentially hitting production where we don't want to have those exposures, those security issues. And while it's great to have security issues flagged earlier, that is just the first step towards shifting security left, meaning now you know that something is wrong, but the next step is going to be to fix that issue, right? How do you do that? Because many teams have been doing this manually because there were no tools that could understand the whole application or infrastructure lifecycle. As I said, we used to work in silos, but today teams have to collaborate, and there are going to be tools that can help us to do that. Not only understanding why something failed a particular security control, but how to solve the issue. So when talking about IAC artifacts, those pieces of code are going to be stored in a Git repository, right? That is a basic best practice for cloud adoption because it facilitates automation. And what I'm saying is that to shift security left, we also need to be able to address misconfigurations on the dev phase during code or build with the same tools that your teams are using to manage infrastructure as code, right? So I would like to show you a quick example with a demo of what I mean. So let me explain you first. Let's say that I have a shop with different microservices running container images, right? And my team finds out that one of the components has several misconfigurations that are also security violations from a compliance benchmark, right? I want to be able to remediate directly into the IAC file so the error doesn't happen again. And that is what I'm going to show you. So if I go here to inventory, let's see, if I search for my microservice, my deployment, and right. Okay, so I have different assets here. The first one is the deployment that is actually running that I'm going to use for the demo. And the other one is the IAC manifest that I've used to build the application. So this small code icon here tells me that is an IAC file. So I'm going to click on the running front-end deployment, and I can see all the compliance frameworks applied to my asset. And for the, let's say, I'm interested in CIS G-key, for example, okay? So now I can see all the control that this particular resource is failing. And if I click on container allowing privilege to process, I can see why it failed, and because the value was not set, okay? For the security context, I have the recommended patch, and I can even open a pull request directly to my IAC code, to the IAC artifact, right? So let me open that pull request. Okay, and if I go to the pull request, and here go to the commit, okay, okay, now I see the change, right? Okay, so as I was saying, this remediation is happening when our shop is already in production, right? But wouldn't it be better to have this security control trigger when I'm coding the infrastructure, when I push the IAC code to the repo, right? So if I come here to the IAC code, I have the same exact controls that I could for this CIS Kubernetes GKE, for example. If I click here, I have the same exact controls that I was failing at runtime, right? So the benefit here is that we can create a fix if anything has misconfigurations in the dev phase, inside the developer or infra teams tooling, right? Okay, and that's for the oops, I wasn't sharing the demo, right? Steve, you didn't tell me. Steve.
Sorry, yes, I was able to. I thought that it was being shown when you were doing this now. Let me see if there's if I have to remove and share, because you are being shared.
Okay. Can you see the Sysdig UI?
I can see. No.
Okay.
Let me
That's
remove
why.
this. Let me remove this.
Okay.
Because I wasn't sure if this was going. Okay. Let's try this again.
Okay, because I want to now share screen. This one.
I don't know why it wasn't, because here I was able to see it on this one, but I wasn't looking at the
okay.
one. Yes, I can see this now.
Okay, perfect. Here is where I was saying I have my deployment that is running in production, but at the same time, I also have the IAC artifact that I use to create my running application, right? So it's great that I can see misconfigurations at runtime, and I have the different benchmarks and compliance controls here, right? And I could remediate directly into the IAC code if I create a pull request, but it is even better if I can do it directly when I'm pushing my IAC code into the GitHub repo. I have the same exact controls here, and if I remediate them in the build process, then those misconfigurations won't be dragged to production, right? Okay. That was what I wanted to explain. So here you can see while this control failed, the security context was not set. So we're giving a suggestion how you could fix this issue, and you can even open a pull request from here, and that will be fixed. Okay. Vale. Now I'm going to come back to the slides. Okay. See, so you can remediate here when everything is in production, and then you remediate at the source, or when you are coding, you can directly avoid misconfiguration or fix misconfiguration before everything goes to production. Okay. Okay, let's talk about the second best practice that we recommend, which is around prioritization. And as things make successfully their way through the application lifecycle, they're going to land in production, right? And if we're talking about shifting security left in the first best practice, it's not because we forget about security at runtime, not at all. What happens is that shift left is something kind of new, but security has always been at runtime. So in the cloud, things are a little more complicated due to the scale and complexity. Anyway, what happens at runtime is that so many of our teams are overwhelmed with thousands of issues that show up in security reports. And don't get me wrong, I mean, it's great that we have the visibility of all those security flaws, but it's not great when we don't know where to focus our remediation efforts. Because trying to make sense of that noise is really impactful, because do we want to spend our day doing that triage and fixing issues that may not impact our security? So what can we do about it? And this is where I want to introduce what we call runtime insights. Runtime insights is what is going to help you understand, one, it is a risk, but two, it is a real risk. Because prioritizing using runtime insights is about the in-use of things. So like software packages that are being used in your workloads, currently executed in a running container, or the permissions that an identity has, but he or she is not using on a time frame basis. And of course, detect those threats that are happening right now, enabling teams to stop threats as it happens. And that's something that we can do with detective methods like drift control. So in case you don't know about drift control, it provides an easy way to prevent attacks at runtime by simply following security best practices of immutability and ensuring containers aren't modified after deployment in production. So by blocking the drift, you prevent the attack. So runtime insights is used to eliminate noise and help you better focus on what really matters to your team, which are the real risks. Nowadays, we have so little time and teams are pretty small that we want to know, well, we need to know what to do with our precious time during the working hours. And I will show you some of these runtime insights benefits after the next third best practice, which is adopt the principle of least privilege. So cloud infrastructure is constantly evolving to support modern application, which creates an almost unlimited number of entry points that organizations need to account for as a result. New projects come and go almost every week. We are provisioning up, staging environments, projects, POCs, all of them have their associated identities. And what we are seeing is that organizations simply lose track and lack the ability to be alerted about inactive identities or overprivileged users. When an identity is provisioned, in many cases, the team that creates that identity doesn't know what are going to be the tasks that the user or non-human identity will do. So oftentimes, those identities are over-provisioned, just in case. No one wants to stop or slow down anyone's job, right? But at the end of the day, some of the permissions that we granted to the identity may not be used at all in the life cycle of the identity. And one can think, well, what's wrong with that, right? Well, identity theft is the first number one thing that starts a security breach. So if credentials that have more permissions than needed are compromised, then we are in a bad position there. Why not reduce the attack surface on our identity fabric, right? So again, a super short demo of what I meant with least privilege, and I'm going to do it well this time. Let me share the demo screen. This one, share, okay. So this time I am going to go to identity and access. And here we have a list of, let's see, users with unused permissions, roles with unused permissions, but this one is even more interesting, policies with unused permissions. So if I click here, I can see this admin access policy that has more than 15,000 permissions, and we are not using many of them. So what you can do to adopt the principle of least privilege is to optimize that IAM policy. And what I was saying before, using runtime insights. So the actual behavior of the users of the identities that are active and operating the infrastructure or the services tells you how to lower down those permissions. So in this particular suggestion, we are decreasing, see, from 15,000 to 600 something. So that's a pretty good reduction, right? You could open the AWS console in this case and just paste the new policy, or open a Jira ticket if you do not manage IAM users. Okay. Okay, and let me go back to the presentation. If I can stop sharing here. Oops, here. Okay, stop sharing. And now I'm gonna share again the presentation. Okay. Good. Okay, so we're getting to the fourth security best practice, which is use hybrid security approaches. And let me explain this. Let's see, cloud environments are super nice because they offer a uniform API-based control plane, right? And this is easily accessible to agentless security methods to identify many types of problems. Agentless approaches to cloud security aim to be unobtrusive and easy to manage while providing visibility into security posture of cloud environments. Agentless methods can provide some visibility into systems where agent instrumentation is impossible or doesn't make sense, such as serverless compute instances, for example. How they work? Well, agentless tools are going to gather data periodically from your cloud provider, compare the current state with the last known state, and report on any changes between the two, right? However, they do not have real-time visibility, so they may miss information about intermediate states of the system between scans. These aspects can create challenges for dynamic and short-lived workloads like containers, right? Which may spin up, perform their task, and disappear, having never been detected by the tool. So real-time cloud activity holds the key to identifying any unusual activities occurring within your cloud control plane among users and across services of multi-cloud environments. Moreover, if we think about all the nodes that compound your Kubernetes cluster, and I want to include on-premise environments as well, majority of these clusters are going to be running Linux OS. So when we tap into them with an agent and look at the system call activity that is happening, that becomes your security camera, the source of truth of what's happening, what's actually being used, as I mentioned before, talking about runtime insights, right? So runtime workload protection is necessary because prevention fails. Even if we run the most robust preventative controls, they would not be perfect. Sometimes the bad guys get in, or our teams simply make mistakes, and we should have detective controls to catch the problem quickly and minimize the impact. So not all detective controls work in real time, but the ones that do require an engine. So favor those approaches that use a mix of agentless and agent methods for security. Okay, and the last security best practices would be to consolidate security tools. Up until now, cloud security has been a patchwork of features like CSPM and scanning solutions, but consolidation brings quite a few reasons why organizations are moving towards that path. Number one benefit is we've seen better identification, prioritization, and remediation of cloud-native application risk. Because all of that happens because we are reducing operational complexity through consolidation of vendors, consolidation of consoles, policies, contracts, thereby reducing chances of misconfigurations or mistakes. When we have a single solution, there is going to be just one single data lake, one data model, and unified graph database for all events. So this enables this solution to deliver against a better vision of risk ops, or finding the root cause of a risk, identifying the person, the team responsible to fixing it, and risk prioritizing the remediation efforts. And just for our closing, I just want to show you the overall picture of the Sysdig CNAP platform. So it is clear to you how Sysdig can help you consolidate all those security best practices that I've been talking about during my session, but you can think of it to all the tools that you're using today and see if they map to your different use cases. So the difference between us and other cloud security platforms is that we leverage all those runtime insights to layer on real-time detection and reveal active lateral movement and initiate workflows to respond to threat events, vulnerabilities, excessive permissions, or misconfigurations. And with that, I am going to finish my session. Thank you very much for your attention. And I don't know if we have time for questions, or maybe they can send them to you, Steve, and then...
Yes. So unfortunately, we've just gone over the time, but what
Okay.
we do is, don't worry, it's okay. I didn't want to interrupt you because I wanted you to make sure that you had enough time to finish it all. So what we're going to do, as we always do, is we're going to send to the entire community both your slides, both yours, Albus, and Ole's as well as any contact links or any links to any projects that both either Sysdig or KubeShop are currently doing. One of the things that they mentioned was about Falco and Prometheus, because there was some interest in the projects that Sysdig is contributing to in terms of open source. But we will definitely let you engage directly with the community. We will be sending this communication out tomorrow, so we should be having some information about that very soon. So with that, I don't want to take any more of anybody's time. Alba, it's been an absolute pleasure having you with us today, and we look forward to counting with you and Ole as well in the future as well.
Yeah, thank you.
Thank you. Bye-bye.
Bye.
And goodbye, everybody. Bye-bye.